first came to Bainbridge Island in 1968. We came over from Seattle to look at the rock formation that I'm standing on. From here, the University of Washington launched me on a lifelong study of geology in many different parts of the world. When I returned here a few years ago, I was surprised to learn how much more we now know about the geology of this region than when I was a student. We have evidence right here on Bainbridge Island of some amazing events in the geologic past. So let's take a look at the rocks and sediments that make up Bainbridge Island and see if we can put together a story, a geological history of this part of the world. If we look beneath the vegetation that covers our island and dig beneath the thin soils, we usually find a mixture of sand, silt, and pebbles that was left behind by glaciers, the last one about 17,000 years ago. But at the south end of the island, the glacial material has been stripped away, revealing something much older. How would we measure how much uplift there's been? Well, one way would be to look at the notch cut at the base of the bluff below me, where the high tide waves are cutting into it, and measure vertically up to the analogous notch up against what used to be the sea cliff back across the terrace behind me. And if you do that, the amount of uplift is about 20 feet. And remember, that would have been all at once. So that's a lot of uplift, and it's estimated that that would have produced about a magnitude 7 earthquake. So our region is being squeezed from different directions. There's an oceanic plate that's pushing from the west and tugging underneath us as it slides below down into the mantle. And we're also being squeezed between Oregon and Canada in a different direction. Now, these conflicting forces should produce complicated structures in the bedrock below our feet. And the more we learn, the more we look, the more that seems to be the case.